we wrote one question. We can continue with that question. Okay. Look at the question given there. One of you read the question. Okay. It is given about the number of death recorded because of horse kick, isn't it? And a table is given. Okay, because of the horse kick, how many of them were died? It is given in the form of table, and you are asked to check whether it satisfies the Poisson distribution. And look at the formula for Poisson distribution. What's the formula? What is the standard form we have learned for Poisson distribution? Poisson distribution is given by e raised to minus lambda, lambda raised to x by x factorial, isn't it? If you write it with k, e raised to minus lambda, lambda raised to k by k factorial. Okay, so now look at the question given here. Femina is there? Please read the question, Femina. The last question, which one we wrote? Read the question once again. Femina. You copied those questions, Femina? Did you copy that question? Yes or no, Femina? Can you hear me, Tomlin?
Yes, ma'am.
Femina, can you hear me? Femina? Yes, Aditya, Satyan, read the question, Aditya.
Ma'am, I was not able to complete that question completely.
Okay, so then write this question. The number of recorded deaths, write the question. The number of recorded deaths due to horse kick. Due to horse kick, K observations. Due to horse kick, K observations are shown in the table. K number of deaths. It's given like this: 0, 109, 165, 2, 22, 3, 3, 4, 1, and the total it is given as 200. Total is given as 200. Total is 200. Does this data provide adequate description for Poisson distribution? Does this data provide adequate description of Poisson distribution? Does this provide adequate description of Poisson distribution? Okay, so these are the numbers given, isn't it? So these are the numbers given. So total is given as 200. So if you want, you can take this as xi. So first let us find out what is pi. What will be pi? 109 by 200, isn't it? For 165 by 200. What is the probability to get 2? 22 by 200. 3 by 200. 1 by 100. So this is pi. Our aim is to find lambda. What we know about lambda? What we know about lambda? Lambda will be same as E of x, isn't it? Lambda is equal to E of x is equal to sigma xi pi. Equal to sigma xi pi. So when you multiply this, 0 into 109 by 200. Plus 1 into 65 by 200 plus 2 into 22 by 200 plus 3 into 3 by 200 plus 4 into 1 by 200. So denominator is same, isn't it? Just you add the numerator. 65 plus 44 plus 9 plus 4. So what you will get? 65 plus 44 plus 9 plus 4. Is it 122 by 200? So when you can simplify this, it is 61 by 100. Am I correct, children? So the lambda will be 0.61. We got the value of lambda. Okay, we have the value of lambda. Lambda. And what is asked here? Okay, once we find the lambda, k values are given as 0, 1, 2, 3, and 4. K values are given as 0, 1, 2, 3, and 4. Is it clear? Up to this, is it okay? Is it okay? Now you can write the Poisson distribution. What is the Poisson distribution? What is the Poisson formula? P of x is equal to A is e raised to minus k, lambda raised to k by k factorial. And here k takes the value 0, 1, 2, 3, 4. K takes the value 0, 1, 2, 3, and 4. Now find out, put different values for k. When x is equal to 0, when x is equal to 0, e raised to minus 0, lambda is 0.61 raised to 0 by 0 factorial. I think that one will be...
E raised to minus lambda.
Sorry, e raised to minus lambda. Sorry, children, e raised to minus lambda. Lambda is 0.61 into lambda raised to k by k factorial. So what is e raised to minus 0.61? Look at the table and substitute the value from the table. What is e raised to 0.61? Negative 0.6. What is e raised to minus 0.6? 0. Is it 549?
Yes, ma'am.
Yes, 0.549. Anything raised to 0 is 1 by 1. So it will be 0.549. Now take the next value. When x is equal to 1, when x is equal to 1, e raised to minus lambda. So that will be 0.549 into 0.61 whole raised to 1 by 1 factorial. Then similarly find out for x is equal to 2. X is equal to 2, 0.549 into 0.62 the whole square by 2 factorial. Then 3, 4. Okay, so do the calculations and find out p of x is equal to 3, 0.549 into 0.62 the whole cube by 3 factorial. And then x is equal to 4. And when p of x is equal to 4, 0.549 into 0.62 whole raised to 4 by 4 factorial. Simplify this and find out what will be the answer. What is the answer for the first one, children? When x is equal to 1, 0.549 into 0.61. What is the answer? Tomlin. Yes, Tomlin. First one, when x is equal to 1, what is the answer, Tomlin? Yes, Tomlin, can you try the answer? Hmm.
Ma'am, sure.
Yes,
489.
489. 549 into 6. 6 5s are 30. Is that no? 0.5 into 0.6 means it is 30. So around 0.3 only you should get. Hmm? Are you able to understand how okay, I'm giving only the guesswork, children. 6 5s are 30. Is that no? So 0.3, around 3 only you should get. What is your answer, Aparna?
Ma'am, is it 0.3348?
Yeah, yes, 0.33 and so on. Similarly, the next one, if you take 0.62, sorry, if it is 0.61, everywhere you should write 0.61. Now, what is 0.61? The whole square, 6 6 are 36, isn't it? So we'll get 0.36 into 5. 6 5s are 30, 5 3s are 15. So you should get it around 0.1 something. The next one. Is it clear? How I guess this work? Is it clear, children? When you do the calculation, like this, you can check. So 6 6 are 36. So you'll get the first digit as 3. 3 and 5 means around 3 5s are 15. 0.1, 1 2 1 3 something you should get. Will not get more than that. So 0.6 into, I'm taking only one place. Okay, 0.36 into 0.5. 6 5s are 30. Then 15, 16, 17, 18. So 0.18 something. Are you getting 0.18 something? Approximate is enough. Don't go for more places. Up to 2 or 3 places is enough. Now look at the next one again. 0.6 into 0.61 into 0.61. The whole cube into 0.549 by 3 factorial is there. Here also you have 2 factorial. Is or no? Again 3 factorial. You divide it by 3 and find out. What will be the answer? When you divide it by 3, what will be the answer? 3 factorial means it is 6, isn't it? I think that part and all you can cancel, simplify. Aditya, Anila Mohanan is there? Karthik, for the third one, what is the answer? When x is 3.
Ma'am, doing, ma'am.
When x is 3, what is the answer? So, if you have completed, please give the answer. All of you, please turn on your video. Aditya, Satyan, Karthik, Tomlin, Femina. Karthik, Tomlin, Femina. What is the answer?
Ma'am is at 0.021.
0.021. X is equal to 3. Yes, is S 0.02. It is given around 0.02. And the next one is 0.003. 0.003. Check your answers. Is it correct? Are you getting like this, Tomlin? Yes.
Yes, ma'am.
So once you get the probability, the question is, look at the question, is the data adequate? The question asked is, you have to check whether it is adequate or not. If it is simply asked, find the probability distribution, means we can stop with this. But here it is asked, is it adequate? Is it correct? Then what do you have to do? Once again, you have to find that lambda value. That means we got the probability. So you find out what is n into p and you check whether you are getting approximately around it. That is, look at the table given here. Okay, here we are having pi values, isn't it? Pi values are there. Now you can add one more column. You add one more column. What is it? One more column here? N into pi. N into pi. So now we got the probabilities. What are the probabilities we got? When x is 0. When x is 0, what is the probability we got? Okay, so we know that. Okay, so to find the Poisson prediction, you find the Poisson prediction, you find out 200 into P of K. You find out what is 200 into P of K. 200 is the total number. Initially, the number is given there. What is the number given there? There are 200. Total number of students is given. Soldiers, it is given as 200. You find the probability. 200 into, what is the probability for x is 0? And x is 0, I think the probability we got is 0.14, isn't it? Now check it. What is 0.14? Approximately, you will get around 108. Similarly, the next one, 200 into the probability. The probability is here 0.33. So you'll get around 66. So look at here. It is almost the same. You are getting 109. Instead of that, you are getting 108. 65. There is no vast difference. This is the data. This data, we are converting it into Poisson form. And you are re-checking it. Is it correct? Is it valid? If it is valid, again, you should get the same data. So how will you check this one? You multiply n into its probability, number of items into its probability. Okay. Is it clear, children? The question, is it okay? You are asked to check whether the given data, if you represent in Poisson form, is it correct? So we are calculating the Poisson distribution. And once again, we find out lambda n there. Once you find the total number of items, you should get the same. Approximately, you should get same. If the difference is vast, then we can't represent it. Here the representation is small. Okay. If you represent it, the difference is very small. Okay. Look at here. We find, and you represent it 200 into 0.5 into 108. You find out n into p. That is what we are doing here. N into p. Number of items into its probability. Are you getting the total number? Okay. Then look at the next case. Again, 200 into, what is the next probability we got there? It is 0.01. So it will be 20. Again, 200 into 0.02. It is 4. Again, 200 into 0.003. So you'll get 0.6, which is approximately equivalent to 1. So more or less same items you will get here. 22, here we are getting around 20. So it is valid. Okay. So representation is correct. The data is sufficient. It is adequate. Finished? Aparna, is it okay? Karthik?
Yes, ma'am.
Shall we do a next question? Aditya, Femina?
Yes, ma'am.
Write the next one. Next question. A traffic engineer records the number of A traffic engineer records the number of bicycle riders. Records the number of bicycle riders passing through that track. He records the number of bicycle riders passing through the track. He records that on an average of 3.2 bicycle riders, on an average of 3.2 bicycle riders use the bicycle track every year. He records that an average of 3.2 bicycle riders use the cycle track every hour. If the number of bicycles follow a Poisson distribution, if the number of bicycles follow a Poisson distribution, what is the probability? Okay, if the number of bicycles follow a Poisson distribution, what is the probability that, first one, what is the probability that, first one, 2 or less bicycle riders, 2 or less bicycle riders will use the cycle track. 2 or less bicycle riders, 2 or less bicycle riders will use the path, will use the track within 1 hour. Second one, 3 or more bicycle riders, 3 or more bicycle riders will use that path. 3 or more bicycle riders will use that path. Also write the mean expectation. Also write the mean expectation and variance. Also write the mean expectation and variance. Also write the mean expectation and variance. So look at here, what is given? A traffic engineer records the number of bicycle riders that use a particular cycle track. Is recording. And once we record, what he is doing, he calculates that an average. It is given as average. Okay, average, we denote this as lambda. It is given as 3.2. Lambda is given as 3.2. Given that the number of cycles that we use follows a Poisson distribution, find, first one, probability that 2 or less bicycles will use the cycle. 2 or less bicycle riders will use the cycle. That means what you have to find? P of x less than or equal to 2. Second case, what is asked? 3 or more bicycle riders will approach the intersection. P of x greater than or equal to 3. And the third one asked is, you have to find what is the mean expectation. We are asked to write the mean expectation and variance. Mean expectation and variance. So this is what we have to write. So lambda is given. Lambda is 3.2. Is it clear? Here it is not the probability. Here it is lambda is given. Lambda is 3.2. Lambda is the average or mean, the expected value of x. So first you write the Poisson distribution. What's the formula for Poisson distribution? Poisson distribution is P of X is equal to R is Rx is equal to K is. Yes, what is the distribution here? Tomlin, give the distribution, Tomlin. Tomlin is present? No. Yes, Aditya. E raised to?
A raised to minus lambda.
Hmm.
Lambda raised to k by k factorial.
By k factorial. Here lambda, it is given as 3.2, isn't it? So when you apply the value, e raised to minus 3.2, 3.2 raised to k by k factorial. This is the Poisson distribution when x is k. And k takes the values 0, 1, 2, etc. Now, to find out the first one, what do you have to find? P of x is less than or equal to 2, isn't it? P of x less than or equal to 2. So 2 are less riders. So x is less than or equal to 2 means we can take x is equal to 1 or x is equal to 2 or x is equal to 3, isn't it? We can take x is equal to 1, x is equal to 2 or x is equal to, sorry, 0, 1, 2, isn't it? 0, 1 and 2. It is not 3. Up to 2 only we have to consider. So when x is 0, you substitute k as 0. So we'll get e raised to minus 3.2, 3 raised to 0 by k factorial. That means 0 factorial. When x is 1, e raised to minus 3.2, 3.2 raised to 1 by 1 factorial plus e raised to minus 3.2, 3.2 raised to whole square by 2 factorial. Now look at here children, from all these cases, in order to do the calculation minimum number of steps, we can take e raised to minus 3.2 as common. Anything raised to 0 is 1 plus 3.2 plus 3.2 into 3.2 by 2 factorial. 2 factorial means it is 2. Now substitute the values. What is e raised to minus 3.2? E raised to minus 3.2. You take the table, find out what is the value, simplify and calculate and tell me what is the answer. What is the answer, Aparna? What is e raised to minus 3.2?
Ma'am, 0.041.
0.051. Is it correct? Others, please check it. The 3.2. Tomlin, is it correct? 0.041. Is it? Okay. 1 plus 3.2 means it is 4.2 plus. If you cancel this, this is 1.6. 1.6 into 3.2. Yes. Aparna, Aditya, Satyan, what is the final answer?
3.8.
3.8. You'll so 3.8 you will not get, because probability means it should lie between 0 to 1. Look at the decimal value. Okay. Yes, Aparna, what is your answer?
Ma'am, 0.3.
Yes, 0.38. Now look at the second part. What is asked in the second part? We are asked to find 3 or more. X greater than or equal to 3. 3 or more means what does it mean? 3, it may be 3, 4, etc. up to infinity. We don't know what is the maximum limit. Okay, we don't know the maximum limit. Then what we can do? We can write this as 1 minus p of x less than 3. We can write this as 1 minus p of x less than 3. So which is same as 1 minus p of x less than 3 means it is same as x less than or equal to 2. Is it correct? Less than 3 means up to 2 only you can take. Is that no? So that is same as 1 minus 0.38. Subtract it, you'll get the value p of x greater than or equal to 3. And third one, it is asked the expected value. Expected value will be same as e of x, which is same as mean, which is same as, for a Poisson distribution, mean will be same as variance. So that is equal to lambda. What is the value of lambda given in the beginning? Lambda is given as 3.2. It is given as average. So lambda will be 3.2. Okay, complete this one. Okay. Is it okay? How to calculate the expected value? Is it clear? Expected value will be same as mean. Mean is same as variance. And we can say Poisson distribution is a limiting case of binomial. Okay, whenever we get number of n is greater than 50, when n is greater than 50 and np becomes small, it will be same as a binomial. Okay, so Poisson is a limiting case of binomial distribution. It is the limiting case of binomial distribution. Is it okay? Is it clear, children? One more type is there, that is for normal distribution. That one we can start in the next class. Okay, just go through up to this. We have to do so many questions, problems we have to discuss. Okay, so that we will be doing more problems in the next class. Tomorrow's class will be doing few more questions based on Poisson. Okay, after that we can start with Saturday. We'll be doing with normal. With normal, almost the chapter portions for first term will get over. Okay, thank you. With this we wind up. Thank you.